your first entry is going to be on solving multi-step equations. So what you can see here is we've got kind of the final version of what you're going to have. There's these two properties of real numbers and properties for addition and multiplication. And that all deals with why we can solve equations the way we can solve equations. And you're going to get these handouts. You should have them. And we're going to go over them in a little bit. After going over the properties, we're going to use the properties to go over these 4 examples. And I'll show you how to make this window diagram. And at the very end, you'll be doing these 2 problems here. So this is a handout you should have. If you don't have it, it's in the folder of the bin that's on the counter. We're going to talk about properties of equality. So when we have an equation, it means that one side is equal to the other. Whatever's on the left is equal to the right, and they're separated by an equal sign. There are certain properties we can use to manipulate that equation to get it to look the way we want it. Like when we solve for equations, we want it to be x equals some number, right? Or y equals some number, or even some number equals x. But in all those cases, x is by itself, right? It's equals x, or x equals. So we need some properties to be able to manipulate equations so it looks like that. The first one is the addition property of equality. And it states that if you have 3 different numbers, a, b, and c, okay, if a is equal to b, like 4 is equal to 4, then a plus c equals b plus c, like 4 plus 3 equals 4 plus 3. And then an example algebraically is x minus 3 equals 2. Well, if I add 3 to both sides, that still is balanced. The same is true for subtraction. If you have 3 numbers a, b, and c, and a equals b, then you can subtract c from both sides, and you'll see that it's still true. And those same properties are true for multiplication. For 3 numbers a, b, and c, if a equals b, then a times c is the same as b times c. And then division as well. 3 numbers a, b, and c, where c cannot be 0 because you can't divide by 0. If a equals b, then a over c equals b over c. So basically, all of these properties are saying that if you do the same thing to both sides of the equation, it doesn't change the fact that the left equals the right, or the right equals the left. But when you do something different, that's when it's no longer equal. It doesn't hold that property of equality. So now that you've seen the properties of equality, we're going to make that window diagram. So you're going to take a piece of printer paper and you're going to fold it in half this way. Try to make the corners match as close together as you can. It doesn't have to be beautiful, but the better you can get it to look, the better it'll fit in your book. You're going to open that back up, and you're going to fold the edges into the middle. Again, as neatly as you can. You can call the teacher over or ask another student for help if you need to. You're going to do it to the other edge as well. So it all lines up. Lastly, you're going to take it and you're going to fold it in half this way. Again, matching up the corners and then making that crease all the way down. So right now we have flaps. If I open this up, it opens up the whole thing. We don't want flaps, we want 4 different windows. So what we're going to do is we're going to take a pair of scissors and open up this flap here and cut along that fold line that you made, the very last one, all the way up to that edge. So it kind of looks like a pair of pants. All right. And you're going to do that to the other side as well. So So what we're going to have is we're going to have one problem, example 1 here. You'll open it up, you'll see the solution. Example 2, open it up, see the solution. And it's all going to fit right in your book. Now that you have your windows, we're going to write down the problems on the front. So example 1 is what value of x makes the equation true? And the equation is 5 equals 5x minus 23 plus 2x. Example 2, what is the solution of, and it's negative 8 times the quantity 2x minus 1 equals 32. Number 3 says solve for x, and it's 1/2 x times the quantity 4x minus 4 equals 16. And the fourth one is find the value of x when you have 3x over 4 minus x over 3 equals 10. So in all of these questions, they're all asking you to do the same thing, but it's phrased differently. This says what value of x makes the equation true. They're asking you to find x. What is the solution of? Asking you to find x. Solve for x. Literally says solve for x, and then find the value of x. It's kind of the same as number 1, just worded differently. So familiarize yourself with these different ways of being asked this question, so that when you see it somewhere else, you know exactly what you're supposed to do. So go ahead and pause the video, and then we're going to get started with number 1. And pause it so that you can write everything down. So we're trying to find the value of x that makes the equation true, and we're given this equation. For the solution, what you're going to do is open the window, okay, and then on the top left corner, you're going to write the equation that you were given. So 5 equals 5x minus 23 plus 2x. And we're going to solve it step by step. You'll notice that I have note cards. I use these often when I'm reusing my notes, so I can, instead of wasting time writing down the steps, just bring it down. So I already hinted towards what the first step is going to be. We've got this equation, and we're solving for x. But notice that I see x twice. It's hard to solve for something if you have it in 2 different places, so we want to be able to make it so that we only see x once. We do that by combining like terms. So that's my step here. I'm going to combine like terms. Now like terms are terms that have the same variable. So I can combine 5x and positive 2x. And when I do that, I get 5 equals now 7x minus 23. So that's what happens when I combine like terms. And now I see x is by itself. Now that's not totally by itself, but I do have just one instance of x. So what is the next step now? Well, I need to get the x by itself, so it's just x. There's no 7, there's no minus 23. So I need to start moving things over to the other side. The inverse of subtracting 23 is to add 23. The inverse of multiplying by 7 is dividing by 7. And when you start figuring out which one to do first, and this is probably the most confusing part about solving equations, is which one should I take care of first, the 7 or the 23? You want to work from the outside in. So this 23 is the furthest away from x, so I'm going to take care of this one first. I'm going to add 23 to both sides. When I do that, I get 28 equals 7x. Now it's all the way back to that one-step equation. The opposite of multiplying by 7 is dividing by 7. So that's what I'm going to do to both sides. And 7 over 7 cancels out. X equals 4, or 4 equals x. And there's your solution. So that is example 1. So So for example 2, again, you're going to open it up and rewrite the equation on the inside. So negative 8 times the quantity 2x minus 1 equals 32. So for this one, I do see x only occurs once. Right, so I don't have any combining of like terms, but I do have those grouping symbols, those parentheses. So dealing with the parentheses, there are a couple different things that I can do. I could get rid of the negative 8 right away, and that would take care of the parentheses. Or I could distribute the negative 8 in. Now you're used to distributing. Negative 8 times 2x is negative 16x. Negative 8 times negative 1 is positive 8. We're not going to go that route because I want to show you something different. Another step that might make it easier is to think about how this is negative 8 times this whole thing. Now if I want to get this whole thing by itself, then all I have to do is the opposite of multiplying that by negative 8, which is dividing by negative 8 on both sides. When I do that, you'll see that those negative 8s cancel right here. And 32 divided by negative 8 gives me negative 4. So I'm left with 2x minus 1 equals negative 4. And now it's that two-step equation, right? I want to work from the outside in. The opposite of subtracting 1 is adding 1. So I add 1 to both sides. You get 2x equals negative 3. Now I need to get x alone being multiplied by 2. The opposite of multiplying by 2 is dividing by 2. So divide both sides by 2. And you get x equals negative 1.5. You could also leave it as negative 3/2. I actually prefer improper fractions, but it all really depends on what you're doing. So we're just solving equations. It's okay to say negative 1.5. And that's it for example 2. For my third example, I'm solving for x with a similar problem to the second example, but now I have a fraction in front of the grouping symbols, those parentheses. So I could again distribute the 1/2 in, right? 1/2 times 4 is 2, so I have 2x. 1/2 times 4 is 2, so I have 2x minus 2. I can certainly go that route. I know you know how to do that, so I'm going to give you notes on the different method. So you're going to, again, open it up and rewrite the problem here. Oops, you can't really see it. So 1/2 times 4x minus 4 equals 16. So I want to get rid of the 1/2, just like I got rid of the negative 8. And I notice that it's multiplying here, right? 1/2 times this whole quantity. The opposite of multiplying is dividing. And that's very true. However, when you're multiplying by a fraction, it's really considered division, right? So the opposite of division is multiplication. So what we want to do here is to get rid of this 1/2, we're going to multiply both sides by 2. And if it was 1/3, you'd multiply by 3. If it was 1/4, multiply by 4, and so on and so forth. So it's whatever the denominator is of that fraction. So those 2's cancel, and I'm left with 4x minus 4 equals 32. And just like the other ones now, step by step, we're going to work away from the x, add 4 to both sides. You get 4x equals 36. Divide by 4 on both sides, and you have x equals 9. So different ways to get rid of that number in front of the grouping symbol. And that's it for example 3. Alright, so on to example 4. This is a pretty nasty problem, right? It looks pretty ugly. we've got 3x over 4 minus x over 3 equals 10. So a lot of fractions here. And the problem with these fractions is they're not the same. This is fourths and this is thirds. It's going to be a different type of problem that you've seen, so we have to attack it a different way. Again, you're going to open it up and write the problem at the top. And I'm going to use my note cards to go through the steps. So this would look a lot easier, right, if I didn't have the fractions. So what I have to think about is, how could I get rid of the fractions? Well, let's see. If I multiplied this term by 4, it would get rid of the 4, and I just have 3x. But if I multiplied this one by 3, it would give the 3, and this would have an x. But I can't just multiply this by 4 and this by 3, because then it wouldn't be imbalanced, right? It's got to be different. I mean, it's got to be the same number. So what's the same thing as multiplying by 4 and multiplying by 3? Well, that would be multiplying by the least common multiple, which is 12. 3 times 4 is 12. So I'm going to get rid of both of these fractions by multiplying both sides by 12. I don't need to write that 12 there. When I distribute the 12 in, 12 times 3 is 36, divided by 4 gives me 9x. 12 times 1 is 12, divided by 3 gives me 4x. And 10 times 12 is 120. Now I see x occurs twice. I want to combine the like terms. So I have 9x's minus 4x. That's going to give me 5x equals 120. Then I divide by 5 on both sides. The 5's cancel, and x equals 24. So when you have fractions in your problem, they're all different fractions. One way to just get rid of all the fractions together is to multiply by that least common multiple. And for this one, it's 12. An easy way to find that is 4 times 3 gives you 12. You could have multiplied by 24, you could multiply by 36, but the least common multiple will make it a little bit easier for you with some easier numbers.
You will solve a multi-step equation. Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. If Martha's total is $67, what is the cost of 1 shirt? What do you know? The bumper stickers cost $1 each. Martha's niece got 1 shirt and 4 bumper stickers. Her nephew got 2 shirts. The total Martha spent was $67. What do you need? You need to find the cost of 1 shirt. What's your plan? Write and solve an equation that models the situation. First, relate what you know. The cost of the niece's items, 1 shirt and 4 stickers, plus the cost of the nephew's items, 2 shirts, is the total that Martha spent. Now, define the unknown by letting S equal the cost of 1 shirt. How can a model help you write the equation? The model shows that the cost of the niece's items plus the cost of the nephew's items is $67. Write and solve an equation that models the situation. The quantity S plus 4 plus 2S equals 67. Now you can solve this equation to find S. First, remove the parentheses. Then use the commutative property of addition to reorder terms. Next, combine like terms. Then subtract 4 from each side. Now simplify. Next, divide each side by 3. Then simplify. S equals 21, so one shirt costs $21.
On the left side of your book, I want you to solve these two problems for the unknown variable. 7 times the quantity 3x minus 4 equals 49. And then 2b over 5 plus 3b over 4 equals 3. And when you're done with that, you're going to show your teacher so they can check the problems and make sure you're ready to move on to the practice. In addition, if you have any questions on the notes you took, ask the teacher and they can sit down with you and kind of communicate maybe a little slower and more in-depth about those steps and maybe give you some separate examples.